Welcome to today's session. Today we'll be talking about advanced data science in the enterprise. We'll cover some basic ideas, and at the end of the session we'll have a couple of demos just to give you a little bit of a taste of what it's all about. My name is Mario Bozilov. I'll be your presenter today. I have been involved with data analytics and data science for over 25 years. I have worked predominantly in large enterprises, government, banking, and also higher education sector on the corporate side. So I will share some of my personal experiences. What you're going to hear today is based on my own experience working in the data science field, both as somebody who was doing data science and also as somebody who has managed teams of data scientists. So without further ado, let me just share my screen and we're ready to go. So advanced data science for the non-tech professional. So first, before we continue, I just want to quickly get your idea, and please use the chat box here on Zoom. What would you like to know about data science? Something that is of interest to you that you don't know yet? What would you like actually to get from today's session? So we'll just have 2 or 3 minutes for this exercise very quickly, and then we'll move on. So what do you like to know about data science? In general, put the questions to me at the end of the session. I will try to answer them time permitting. Great, we have some questions coming, so we'll continue now. Please feel free, just keep sending the questions into the chat box and we'll get to them at the end of the session. So let's keep going. First, let's talk about what data science actually is, because if you do a search on Google or you start looking through some online sources, there is a lot of different opinions and definitions. So we'll just go first with what Wikipedia says. So data science uses scientific methods, processes, and algorithms to get knowledge and insights from noisy, structured, unstructured data. The data is never perfect. The data that we have to deal with comes in various forms. On top of that, quite often it's not clean. You have duplicate names, duplicate addresses, incorrectly entered fields, all of these things. So we actually want to get some knowledge and insight from that. Now, data science is related to data mining, machine learning, and big data. Yes, definitely, and this is what we'll be talking about today. So these are all parts of data science. But there's something else which is really, really important in my opinion. And you see here, this is Peter Drucker. He is one of the top management consultants of the 20th century. He passed away, I think, in 2003. So what Peter Drucker says in one of his books, the purpose of information is not knowledge, and that was specifically related to the digital technology and how managers need to deal with it. The purpose of information is not knowledge. The purpose of information is being able to take the right action. And this is really important. We don't want to do data science just so that we can get some idea.
Mario,
Yes.
I'm sorry, we cannot see the presentation.
Oh, apologies for that. Okay, yep, all right. Okay, sorry about that. Let me just go back quickly, a couple of slides. So data science definition, this is what I mentioned before. Using scientific methods, processes, and algorithms to get knowledge from various types of data. And it is related to data mining, machine learning, and big data. However, talking about data science, Peter Drucker, the management consultant that I just mentioned, said the purpose of information is not knowledge. The purpose of information is being able to take the right action. Ultimately, this is what we want to do with data science. We want to get something which would allow us to improve our work, our organization, our life, and so on. So we don't want just to know things. We want actually to have what they call actionable insight. When you get that piece of information from the data, as a result of some data science exercise, what exactly are you going to do with it? Are you going to just have it as an interesting bit, or would you be able to actually take a specific action based on it and improve the organization in some way? Okay, so let me just give you an example. Let's say we do a data science and we want to work out, and we do some data science and some predictive analytics or prescriptive analytics, and we work out that there is a specific salesperson in our organization who constantly outperforms everybody else. He's an average salesperson, okay? Just where the others are, maybe in the top 30, 40% of the salespeople, nothing extraordinary. But if we dig a little bit deeper, we notice that this person actually outperforms everybody else in relation to a specific product. Okay, the question is, what do we do with that? Is that just nice to know? Or alternatively, can we go and talk to him and see what he is doing? Maybe we can get him to run a training session for the rest of the team just to share his experience, because obviously he's very good at it. He outperforms everybody else, specifically on that product. There is a lot of really valuable knowledge inside that person's head. We want, from an organizational perspective, to actually get into his head and see what's there, get him to share. So this is what being able to take the right action, not just knowing, yes, okay, he's really good and his commissions are really good and so on and so on. No, we want actually to do something with that information. We want to improve the whole organization, not just that person. So this is what being able to take the right action means. Now, some other considerations in relation to data science. Data science is about business outcomes. Okay, this actually fits back into what I was just saying that Peter Drucker mentioned. So we want to focus on the business. No matter what we do, we want to focus on the business outcome. It is not a technical initiative. This is a really important thing. Very often, and I see it time and time again, data science actually is given to the IT department to deal with. While the IT department has got a very important role to play in this whole exercise, they are not that need to drive it. On top of that, they are not that actually have all of the knowledge which is necessary. I've spoken to tech people. I know, because I come from a technical background. My career started as a C programmer. If you've heard about C, that's a language which is way before C++, which is currently one of the popular languages. I was programming in C. I was a database administrator. I know in those days that I had almost no idea what, I knew what the business is doing, but I had no idea what we were doing here with the databases and the programs I'm writing and so on and so on. I was always focused on how to do things. I never understood what quite well, and I was very far away from why. it is the business people who tell me, Mario, write this program, or Mario, we want to put this type of data into the database. And my job was to work out a way to put it in quickly and to be able to give them a way to access it quickly. That was it. So do not make the mistake just because it's got the word data, which is a technical term, that this is a technical initiative. It's definitely not. It needs to be driven from the business, and the more business people are there involved in it, the better. Now, it is not specifically data mining, big data statistics, etc., although all of these play a part of it. But this data mining is not data science, okay? Not is big data or statistics for that matter. Now, data science also can be as simple or as complex as needed. Now, today we were talking about advanced data science. However, 2 weeks ago, we were talking about introduction, foundations of data science. So you can start doing some simple things which are still data science and move progressively towards more complex things. Now, well, if you think about football, the way a kid in the school plays and the way David Beckham plays, there is that much difference. Their universe is apart, but it's still football, right? Both of them are classified as football. It is the same here. So do not think that it needs to be something extremely complex. Actually, the most logical thing is that you can start simple and then move on from there. And also, it is an activity that 50 to 80% of business professionals can do. Now, I'm not saying 50 to 80% can do the complex stuff, but some of the foundational things in data science, 50 to 80% of the people can do. And it is important, very important to get them to do it, because the business people have got the knowledge. They know what needs to be done. They know what the business questions are. I was talking to a person in Malaysia. He came to one of my courses that I was running in KL before COVID. And he said, listen, I was made responsible for the implementation of a data lake. Data lake is a type of big data initiative, very closely related to data science. Actually, data lakes are one of the main elements of data science. And he said, we did it, but now nobody knows what to do with it, and everybody is blaming me. He said, I'm a technical person. My job was to manage the implementation and not to keep it operational. I don't know what the business questions are, but the business is not coming to me to actually help them to ask those business questions. So just keep that in mind. It is a business, people need to be involved. When I say business people, I mean people from HR, marketing, accounting, finance, and so on and so on, pretty much any part of the organization. And it doesn't need to be too complex. 50 to 80% of the business people can do it. There are some people who flatly refuse to do it for whatever reason. I've seen those. But generally speaking, most people are okay, and they can do it. Now, so what about all of these things? Data science, data analytics, data processing, again, a little bit of a confusion. This is the way I see things based on my personal experience, as I said, over 25 years plus. At the beginning, we have data processing, okay? We need to store the data somehow, somewhere, in order to be able to do data science and in order to be able to do all of the other things that we want to do with it. So we need to store it and we need to pre-process it. Most of the data is, at the best, a little bit messy. Usually it's very messy. So it needs to be pre-processed, it needs to be cleaned so that we actually can start using it. There are mistakes, human mistakes, software mistakes. Sometimes it's not even a mistake. There are two pieces of software that have been implemented 10 years apart, and one of them is storing a certain field in this format, and exactly the same field is stored in a different format in the other piece of software, and on top of it, it's got a different name. So all of these things need to be sorted out. That's the data processing, the storage and the pre-processing. And after that, we move into data science. Okay, that includes big data, that includes artificial intelligence and machine learning, that includes various types of databases, because without a database, actually, it's very difficult to do any data science. It's possible, but you will be able to do some pretty basic stuff. That includes data warehouses where we can actually link business intelligence, big data tools, and other tools in order to extract information. And within that sits data analytics. It's part of data science. It's basically the start of the data science, where we can do some simple things using Excel, using KNIME, another tool that we're going to do a quick demo for you today. So this is how these terms are related. Data analytics is part of data science, and data science is part of data processing. Data processing, okay, this is everything that an organization does. It includes the storage, the pre-processing, running the analytics, getting the insights out. Okay, so let's keep going. What about data science in the enterprise? So data science needs to be part of daily business activities. Very rarely it is. Some organizations are actually starting to get down on that path. By the way, I need to say here that data science can be done by large and medium enterprises. For the small enterprises, they can start dipping their toes in the water as well. Maybe they don't have as much data as a medium to large enterprise, but nevertheless, they still can get some benefits there. So it is for everyone. It is part of daily business activities. Eventually, we want the organization to get some insights based on real data, not just on gut feeling. By the way, I'm a big fan of gut feeling, but when it's actually supported by data, it's even better. So we want to get insights based on hard code facts, not just on what we think, because sometimes gut feeling can lie to us. It does lie to me. I'm pretty sure it does happen to all of us. Data science also is not just about software. People often say that, okay, well, we'll put some sort of some piece of software and we'll be doing data science. Not really. Data science is about process to start with. There needs to be a process. How exactly are we getting the data? What exactly are we doing with the data? How exactly are we processing it? How exactly we're getting the outputs from that data and then providing it to the relevant people. And by the way, who are the relevant people? And how often are we giving them the insights? Are we giving them on a weekly basis, on a daily basis, on a quarterly basis? So all of these things are part of the process. What are the data sets? Now, when we talk about data science, we're talking about multiple data sets. This is one of the strengths of data science. We are not limited anymore to a single data set. We want to actually link things. We want to link the sales transactions from one system to the HR system to see what are the salespeople who actually are linked to those sales transactions. We want to be able to see analyze and see some characteristics of our salespeople selling specific products within specific regions, just as an example. Or maybe we want to link the invoice data set from accounts payable to the vendor data set and to a data set which shows our deliveries from our warehouse to see which vendors actually deliver on time, which vendors are constantly late, which means that it will be causing problems for our organization. So maybe the vendors who are consistently late, like let's say 50% of the time or whatever, maybe we need to have a chat with them, and if they keep doing it, maybe we have to drop them from our panel of preferred suppliers. All of these things. But the point is that we need multiple data sets. One data set is not enough anymore. And then it's also tools. Of course, we need tools. It can be Excel, it can be Power BI from Microsoft, it can be Oracle BI, it can be KNIME, which is a data science tool, and you will see a demo of KNIME at the end of this session. So the tools are part of the mix. But you just need to keep in mind that it is all of these components, not just one thing, which is the data science. And by the way, data science or no data science, what we want to achieve is still there, okay? Data science is there to support the business. It doesn't change the objectives of the business. So if we are opening a new market or in a new region, or we're opening a new subsidiary, we are not going or introducing a new product in a specific part of the country. Let's say we decide to try to test the market in Sarawak or Sabah, and then we decide to do the same thing in KL or in Johor. That doesn't change. We use data science to make the process more efficient, but just because of data science, we're not going to decide, no, we're not doing that, or we're going to do 3 times as much. if we decided to test the product in 2 of the states of Malaysia, we stick to the 2 of the states of Malaysia, all right? The business objectives stay the same. We may be able to actually finish those tests instead of 3 months, in a month and a half, because we use data science, we can get the insights much quicker. That's a different thing. However, the business objective doesn't change at all. Some of the benefits of data science in the enterprise, we definitely can get improved profits and performance. Now, what you see here is basically using data science by a chain of restaurants. I don't know which one. This is an article that is published by McKinsey & Co. and company, the consulting outlet. They don't say which, but restaurant chain, but think something like McDonald's or Burger King, Pizza Hut, something like that. Anyway, so they're using data science and looking at the performance of their stuff and suggesting some improvements. They actually got the customer satisfaction to increase by up by 100%. Okay, within 4 months of actually starting the initiative. Now, 100% customer satisfaction increase is a lot. That means definitely increased profits. Sales also increased by 5% in 4 months period. Now, how? Just think about it. Just using data science and introducing some changes based on that, but no additional infrastructure and no additional huge capital expenditure, they managed to increase the sales by 5%. How easy it is to increase the sales by 5% for the average commercial enterprise? It's not easy in most cases, because most enterprises already operate at fairly peak performance, so actually squeezing another % or 2 is quite difficult, and we're talking here about 5. New insights. Now, using data science, we can actually understand some things, and actually we can bust some myths. So as you can see here on the right-hand side, we can see what the things that people in the organization thought are real and which things are not real. So affected outcomes. So if you look at the top one, personality traits affect the outcomes. So they looked at what the people who are serving the customers are doing. All right. So personality matters. Fair enough. But when I look at the next one, the next red circle, about 4 down, it turns out that the commute distance matters as well. Now, personality being important, I think most of us intuitively will get it. But the fact whether somebody lives 1K from the outlet or 15K from the outlet, I don't think that many people actually even were thinking about that. Other things that are important, shift length affects the outcome. Well, obviously, if people are working longer shifts, they are not performing as well. Okay, but then if you look at some of the mythbusters, like these are the gray circles with the red border. So turns out, the first one from the top, previous retail experience doesn't matter. So it doesn't matter whether they had experience or not. It didn't affect the outcomes. Then, even more interesting, when you go further down, that's the 5th from the bottom, compensation structure. Turns out the way they are getting paid in terms of bonuses and whatever compensation didn't make too much difference either. So it doesn't matter whether the commissions were high, the bonuses were high, or the bonuses were average or moderate, didn't matter at all. So it turns out that actually things that we think we take for granted, we always look for people who have previous experience in our industry, and we always think that the more we pay people, the better. Turns out that that's not the case. But some people would have said, yeah, I knew that. But it's a very different thing when actually you get the hard-code facts to support that. This is where data science actually really helps. Because nobody can argue, no, maybe you're right, maybe you're not right, all of these things. No, now you can say, yep, that was my opinion. I expressed it last month or whenever. And by the way, here the data shows that. So we shouldn't be just focusing on money and retail experience. We should be focusing on other things. Because if you look at one of the other affected outcomes, somewhere in the middle, training and capability building. So it turns out that training is much more important than how much you pay people, to put it simply. So this is just an example. This is in relation to managing stuff within a specific environment, showing how data science actually contributes increased profits and performance and new insights on what we need to do. And this is just a very small example, but basically the same thing applies to pretty much any part of the enterprise. So how can we do data science? Where can we do it? Now, the data science has got data in its name, so we need processes that are highly automated and data rich. For medium to large organization, that's the majority of the processes now. So it's relatively easy to start with some of these things. Here are some examples. Payroll in most places is now fully automated. Even for small organizations, it's fully automated because they're using some cloud software like Xero or MYOB if you're an Australian company. I know MYOB is available around the world, but it's more popular in Australia. Quicker and so on. So you have the data. If you have 20 or 30 people, you actually have enough of a data to start looking at some insights and some dependencies. Purchasing. Okay, what are we doing with purchasing? So invoices, delivery times, performance of vendors, and so on and so on. Maintenance, depending whether we are a transport company, Malaysia Airlines, or some shipping company, or whether it's a bus and truck company, all of these things we can actually start looking using data science in our maintenance department. Sales is an obvious one. Who is the top salesperson per region, per product for the company? What are their characteristics? What can we do? So remember talking about the restaurants. The same thing applies here. So personally, I think that if for the people serving the customers, previously their experience is not that important and the compensation structure, that probably is just as valid for salespeople. If you train the people, if you explain to them what to do and they have the right mentality, that's a totally different thing. And we can analyze it to see where the things are. And any other part of the enterprise, basically just anything that's got data and anything where you get access easy to the data is a good starting point if you're not already doing it. So what are some of the requirements? How do you do that? Now, again, this is here based on my personal experience. There are different theories. People have their own opinions. Now, for me, to get central data repository was one of the keys in every single project that I was part of or that I have run myself. Because once we have everything come into a single place, it's much easier, to start doing various types of analysis. One of the major problems in every data science exercise is access to the data. Once the data is in a central place and that access has been negotiated, agreed, and signed off by various business owners and technical people, it's much easier from that point onwards. So central data repository, you don't want to be able to have to pull data from the HR system and from the sales system to do some analytics on salespeople performance. Number one, it's very difficult because you may or may not get it all the time that you need it. And number two, it's actually quite risky to be touching production systems because you don't know what you can break. Again, speaking here from experience, I have broken systems. I have people working for me break systems. We didn't destroy the data. We just impacted the performance of the system, and then everybody started screaming, "What are we doing?" So having everything, most organizations do have something like a data warehouse or data lake already. So you can piggyback on that. If not, most organizations have got blanket licenses for either Oracle or Microsoft SQL Server, and it's very easy to deploy a database instance and start using it. Number two, transfer automation. I'll repeat it again. One of the major problems is getting access to the data. We want data transfer to be automated. It's very painful to negotiate data access, okay? because it requires a lot of diplomatic skills. You have to deal with a lot of politics, both business and technical, because data access is controlled by the business owner. Let's say if it's HR, by the HR director, and also by the technical team who is responsible for the HR system. So you have two parties. Now, however, if you automate the transfer to get the data from the system every week or every month or every fortnight, whatever, you have to go through the pain once. And once it's automated, you have everything that you need to be able to do data science on a daily basis. Otherwise, it will be very difficult. And we want to actually focus on some complex things. We don't want to do a sorting, something that can be achieved by sorting in Excel to get what is the top selling product. Okay, that's important, but not as important to know what is the top selling product per person per region or per country, for example, if we're a multinational. So we just want to start digging deeper, not simple things, because that would lead to some disillusionment in management, and also some skepticism. So we can, but it's possible to actually start looking at that quite easy. Now, so some of the elements, some of the ways to do data science, number one, business intelligence. A lot of organizations already have business intelligence installations, and they're using them for various purposes. Business intelligence is a very business user-friendly way to access the data. It allows data exploration, which in my opinion is one of the keys, simply because you want the business people to be able to run and rerun data queries, or essentially asking business questions many times on their own. You don't want business people to have to pick up the phone and say to somebody in IT, please send me a report on our sales in March for Johor. And then 1 hour later, when they get the report, if they get it within 1 hour, which is almost an impossibility, but hypothetically speaking, when they get the report, suddenly they realize, no, I don't want the sales for March. I actually wanted the sales for February. So they have to pick up the phone again and say, by the way, can you run me a report with the sales from February from Johor? And after they do that 4 or 5 times, at the other end, they'll stop probably taking their calls, or they'll be waiting forever. But if you have actually the ability to do and run and produce these reports on your own, which business intelligence does and allows people to do, it's much easier, because this is the real power. We want people, business people, not technical people. We want business people to be able to do the data exploration and ask all these business questions. Now, business intelligence makes it easy to get a lot of information very quickly, based on data cubes which are sitting inside pretty much every business intelligence implementation. So data cube is actually a summary of the information which is available from the transactional system. So here we have a data cube which shows the customer, the store location, and the part, and maybe that's based on 2 million transactions that have been collected over the last 4 months. Now, every time when we want to ask a new question, we don't want to be able to have to go through 2 million transactions, because every time we change the question one bit, we need to process the 2 million transactions again. But the data cube actually saves it, because here I want to know what's happened in Vancouver, here at the bottom. And then if I decide that I don't really care about Vancouver, I want to see what's happening in Calgary, the second square at the bottom, I can just very quickly rerun the question without having to go through 2 million sales transactions. So this is what data cubes do. They basically, based on some dimensions, the so-called dimensions here, or the criteria in normal language, in everyday language, here the criteria are part, location, and customer. So we can ask any question. Basically, we can ask, who is our best customer for part number 2 in Vancouver? Or who is our best customer for part number 4 in Montreal? This is what the data cube does. Usually we have more than 3 criteria. Here it's only part, location, customer. but that's done in order to visualize it. Usually the data cubes have 5 or 6 different criteria as a minimum, but visualizing a 6-dimensional data cube is a little bit of a challenge for all of us. But this is what business intelligence does. So with business intelligence, we can give the business people the ability to explore the data and to become much more productive. If the business person, if there's no business intelligence and the business person has to ring every day or every couple of hours to get a new report, nothing's going to happen, basically. The other thing is big data. Okay, big data is coming more and more. We're all dealing with increasing amounts of data. Here you can see how the data volumes are rising. Big data has got 3 main characteristics. The first one is volume, and you can see here the increase in volume. We'll be dealing with more and more and bigger and bigger amounts of data. And this is a challenge for a lot of the traditional infrastructures. The database vendors are doing their best, and they're catching up, like Microsoft, Oracle, and others. But there are some dedicated big data vendors who actually started with that, and they're doing a better job at this point in time. So we just need to keep in mind that we'll be dealing with increasing amounts of data all the time. The second thing is velocity, how quickly the data gets created and how quickly we need to actually query the data. Now, I'll give you an example. 20 years ago, in Malaysia, probably there were very few FPOS terminals, or 30 years ago. Last time when I was in Malaysia in 2019, I got 400 ringgit at the airport. I stayed 4 or 5 days in Malaysia, and the 400 ringgit was more than enough because I was paying absolutely everywhere by card. Now, every single payment by card is a transaction, is a data point. So actually we're talking now, compared to 20 or 30 years ago, we're talking about some huge amounts of data that are generated very quickly. They're not just generated, they're generated quickly. So just imagine how many transactions we have per day, or just in electronic payments, in Malaysia or around the world. Huge. And how quickly we want to actually analyze them, because if somebody has stolen my details and I make a payment transaction in Malaysia, I pay 200 ringgit for something, and then 5 minutes later, somebody in Brazil using exactly the same card pays for something, let's say 10 bucks or whatever, we need to be able to pick that up straight away in order for the bank to tell me, Mario, there is a problem. Please, we'll stop your card and we'll just investigate, which, by the way, actually happened to me 4 weeks ago. Suddenly on Sunday morning, I'm waking, it's COVID, I haven't been outside Australia for 2.5 years, and suddenly somebody did a transaction on my card in Canada. There were 2 transactions for $300 or something like that. But the bank realized what it is and stopped it. So this is the velocity. We generate data very quickly. We have to also very quickly be able to query it. And then the thing is variety. This is what we are currently doing. This is the statistics from 2019. But as you can see, every minute of the day, at the top is Netflix. Users stream 649,000 hours of video. That's per minute. Now, if we look at Instagram to the right, users post 277,000 stories on Instagram per minute. Then if we look at Uber at the bottom, every minute users take 9,772 rides. Probably something similar for Grab, if not higher, because Grab is operating in pretty much the whole of Southeast Asia at the moment. Okay, so this is the type of data that we need to analyze. No matter where your company, what space or industry your company is, you're dealing with increased amounts of data. Maybe there is a lot of sensors, maybe there is a lot of sales transactions, maybe there are some other things that you need to process, but this is what we're doing. So it's quick, that links to velocity. but it's also different variety because Grab transaction is very different from a Netflix transaction. It's very different from Facebook transaction. It's very different from the transaction in the payroll system when we have a payment run. Very different. We have to have a different way of processing each bit of information. We have to have a different way of actually extracting the most important part of the data and turning it into information. So this is big data. Again, this is what we're told this is what we do when we talk about advanced data science. And the next one is artificial intelligence. So when we talk about artificial intelligence, it is basically we try to make the computers think in the same way as us, in an abstract way. Okay, think about this. When you see a black kitten and a white kitten, you know that it's a kitten, all right? When a computer sees a black kitten and the white kitten, to the computer, that's two totally different things, all right? So now we actually have to get the computer to think like us. How do we know that both of them are kitten? I'm not a neurologist, I cannot really explain that, but very quickly in our brains, something goes along the lines, okay, it's meowing, it's got all those prickly ears, it's similar size, blah, 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 must be the kitten. And by the same token, when we see a black kitten and a black puppy, we can still work out pretty quickly that it's actually a different thing. Both of them are black, both of them are similar size, but again, as humans, we can work out pretty quickly that they are different. This is what we want to actually teach the computers. This is what artificial intelligence ultimately is. We're not there yet, but slowly, maybe one day we'll get there. At the moment, we are mainly in the area of machine learning. And machine learning is a type of data science activity which fits within artificial intelligence. Basically, Siri, for those of you who use Siri or Alexa or Google Assistant, when you go and say something and the system recognizes what you are saying, they're getting better, I must admit. When you hear my deep voice and strong English accent, I had a lot of trouble before with these things. They are starting to understand me better and better. This is because these systems have been trained. They have been shown lots of, excuse me, they have been shown lots of recordings of how different people say the word cat or the word computer, and eventually they learn. This is what machine learning is. We present lots of data to a system and eventually it starts recognizing some patterns, just the way we do, some patterns, and it can work out that when I say the word computer and a 5-year-old kid says the word computer, they are the same thing and it will recognize as a computer. So this is what machine learning does, and deep learning is just a subset of machine learning. It's still relatively in its infancy, not as widespread. Deep learning and machine learning are the things that are used by self-driving cars. We don't see many self-driving cars on the road, but they are getting better and better. But basically, a self-driving car, think about it, a self-driving car when it's driving need to be able to see that that black bit on the road in front of it is either a shade coming from the lamp post on the side and drive over, or a branch of the tree which it needs to stop before it. Okay, now the self-driving car just takes a lot of images, black, white, or color sometimes, but and it needs to make the difference. So there's a black strip across the road. The question is to work out when it's a shade and we can drive over, or when it's a real branch and we need to stop just before the branch. This is where machine learning and particularly deep learning are coming in. Deep learning requires a lot of computing power. I don't think that many organizations are doing it. And when I say many, I'm talking even about the top organizations in a country, banks, retailers, and so on and so on. They are still dabbling in that. Organizations that use it a little bit more, organizations like Amazon or Microsoft or Google who use it for internal purposes, and they also sometimes actually they expose the results of deep learning or machine learning to their customers to provide certain services. So this is the session. Now, what I want to do, I want to show you 2 quick demos of what we do in our courses, and these are just some ideas about data science and how you can start. So just give me 1 second. I will stop that and I will share my screen. So here, what you see, this is actually one of the exercises that we do on our data science course. I'll just do one part of it, just want to give you an idea of what we do, because it's very important to keep in mind that data science is not just about programming. Actually, you can do data science with almost no programming, and this is what we'll do. Let me actually just stop, share my screen slightly differently. So, okay. So here, all right. So here, on the right-hand side, you will see the tool that I'll be using. On the left-hand side, the actual instructions for the tool. Okay, so this is what the scenario is. The activity, we're going to read an Excel spreadsheet and we're going to identify excessive and unusual payments to employees. We're not going to go to the others because it's just a demo. So first, we need to get the data set. I'll get it in a second. Start NIME, number 2, start new NIME workflow. I have already done this. This is what you see here on the right-hand side. This is NIME, the tool that I mentioned. Okay, and we have the workflow created. So now I want to select Excel Reader from the node repository. So here's Excel Reader. I've selected it. I will just then go and work out where the file is that I need, and payroll data set. Okay, I'll click on OK, execute. I have read the full Excel spreadsheet into my computer now. Okay, so no programming here, as I said, just drop and drag and drop these little colorful blocks on the screen. Now, I want now to just filter on something, select row filter. So I will select row filter from the node repository, row filter here. I'll drop it. It's already connected automatically. I'll double click on it. And I want actually to see, to get the amount where we have more than 5,000. So I want basically to get all of the records that are more than $5,000. Lower bound is 5,000. So there is no upper bound. So basically it's unlimited. Okay, click on OK. And then this is what it looks like. The screen, I will get the interactive table. Interactive table local, I'll connect it like that. And then I'll click on execute and open views. And this is what I see here. Okay, I have 4 records which show me the big payments from different big, I mean, everything above $5,000 in the amount column. If I want, I can sort it. Okay, so 5,000, 6,000, 7,000, 150,000. The different departments are sold by departments. So I have a question here. How many payments are there for marketing? And if I look at column number 4, department, this one here, I can see that there for marketing, there is 1. For accounting, there are 2. And for payroll, there is 1. I'll check. Yep, my answer is correct. Great. Then, are there any unusual payments? Yes, there are some unusual payments because all of the payments, 3 of the payments are around 5, 6, 7,000, and there is 1 for 150,000. Yes, there are unusual payments. From which department? Well, let me just have a look. This is the payment here from accounting. Let me just check that. Oops, it's case sensitive. So accounting, check. Okay, this is, I'm right. My answer is right. This is what we call data science 101, very basic stuff, but you don't need to do any coding. You don't need to do any, you just need to know all of these little blocks here. How do you actually link them, and what you need to do with them, and how do you, so you need to configure them. You obviously need to know what they are. You need to configure them, but there is no programming. And we are starting with data science. What I want to show you now, actually, in relation to data science is, give me 1 second. So I'll show you the full screen now. This is here a very complex data science. This is data science that includes, in the same tool, by the way, which is free. This is data science that includes artificial intelligence, it includes big data, it includes various types of visualization. This is a system which I have developed for synthetic identity fraud detection for banks. Okay, so now I will just reset. So all of these things here that you see are various nodes. What you see here in the yellow frame, the little things is, sorry, these here are the normal nodes, but when you have a look here at the gray nodes, each one of these gray nodes, and I will just try to, okay, so each one of these gray nodes here is actually the so-called meta node, which contains other nodes. Okay, so this is just one example. Here there's another, what is it, about 15 different other nodes. But what I want to show you, my point is that actually using 9, we can do simple things and we can do very complex things. Now, I showed you the simple one. What you can do is 3 nodes. This thing here contains over 150 nodes. I haven't counted them, but they are somewhere there. It does here, it does at the bottom in the green frame, it's neuro-linguistic, it's natural language processing, does topic classification, analyzes Facebook activity and friends acquisition in the blue squares here, looks at Twitter activity and so on. And by the way, at the end, it calculates a risk score for people in the bank to work out is this application good or not. So we'll just run that risk score, and it takes a little bit, probably a few seconds. But by the way, it just did 5 different analytics types, and here it analyzed what you see here. It analyzed Facebook activity, green, Facebook friends, green, because synthetic identities cannot have activity which is too long or too big number of friends. Topic answer looks suspicious because one of the questions is how, this is for credit application. The question was, how are you going to repay the loan? So the system didn't like it based on previous experience. Twitter activity is not good, another yellow one, and then we have Twitter followers, which are good. So very quickly, a bank officer can work out what's going on here and see what they need to focus on in order to check that application manually as opposed to getting it processed, approved automatically by the online banking system. Here, for some more information, these are the actual results from analyzing Facebook and Twitter activities on a specific person. This is my own data, by the way. So you can see my own data, my Facebook activity in the top left corner. 2014, 2013, not much, that's why it's red. 2018, I've done a lot of posting. It's a thick line and green end. My Facebook friends, same thing, top right corner. Initially, there weren't that many, and after that, they just grew. My Twitter activity, top left, looks a lot to be desired. This is not my real account, actually. This is simulated. But for this account, the activity is bad. So it's obviously suspicious, and my Facebook friends, bottom right corner, seem to be okay. I didn't have many friends in 2007, but after that, things seem to be okay. So these are just two things which look at data science and just show what, where's my, okay. So what data science can be done. So we're talking, we can go from very simple things to extremely complex things. We can do it in the same tool. And by the way, this tool is free. That's one of the reasons we use it. Number one, it's user-friendly. Number one, the licenses are free for corporate use. So this way, we can basically, when we run our courses, it's much easier for us, because otherwise people start talking about licenses. Some participants do have licenses for one thing, some people for other thing. But here we're solving that problem, and on top of that, it's much, much easier. Before I finish, just quickly, I want to mention something. We are having an introductory data science session coming on the 9th of June. That's in 3 weeks' time, or a little bit over 3 weeks. You will get the information after that. So basically, we are using, it's a data session. It's a session based on 9, the tool that I just showed you. Just to give you an idea how you can start with both data science and 9. This is the program overview. You will get, it's an online session run by myself. You'll get the link to that one in the presentation. It describes the length, starts at 9 o'clock in the morning. KL time goes to 4:15. It's got the program overview, the learning outcomes, the outline. At the moment, until Sunday, we have a 30% discount. As you see at the bottom when you register, it's not $149, it's $119. So have a look at that if this is something for you and your team. Speak to your team, because if you bring several people, you can share ideas between yourselves. If you bring more than 7 people, we can actually run it in-house just for your team. Otherwise, it's a public session. You can register for it. This is the full link that you will receive together with the presentation after we finish the session. You'll get a certificate of attendance, the presentation, and the video. If you register before 22nd of May, which is this Sunday, by the end of Sunday, sorry, you'll get a 30% discount. You can get an additional 5% discount, so that will be 35 when you book with one of our team who are present here. So ask us if you don't know, if they haven't contacted you, just say that you want to book through one of our team, and we'll refer you to them. So this is basically it. Any questions? This is how you can reach us. I will just have very quickly now at the chat to see some of the questions. How can I switch into data science job? Okay, look for a job like that. You need to have the basics of the data science. As I said, don't need to be some sort of a PhD to go into that. You just need to be able to work with data, to have the desire to work with data, because a lot of people don't want to touch it. And you can start with some simple things. As I said, data science is not just about machine learning and artificial intelligence. Data science can start with simpler things like the one that I showed before. Application and case studies regarding data science. We had one that I showed with the restaurant chain in relation to HR. There are others. We just simply don't have the time to do it, but please do send me an email if you're interested. I do have others. How can both structured and unstructured data be compiled and read to know the insight and used in audit? Okay. My background is in audit, as some of you may know. Structured and unstructured. Okay, so unstructured data, for example, is all of the data which sits in Word files or PDF files or emails. So what you need to do is basically extract the content of a Word file as text. That's very easy. You need to speak to some of your technical people, or get the text of an email. Again, just the email body, or sometimes it's even enough if you get just the text, the subject line of the email, together with the time when it was sent. Have a look at that and then link them together with the data, with the structured data. Like, for example, you can see what are the topics that a certain person from HR, from the organization, so this is HR structured data, structured data is emails. You don't even need to know actually the topics. Well, you can actually just have a look, and I've done that exercise for a client a few years ago. You just want to know how many emails that person has sent to specific people. Is there some unusual increase? Because if normally a person sends 10, 20 emails per week, and suddenly they started sending 200 to one specific person, this is something to be looked at. So this is one of the ways that audit can do. Okay, does data science include any invention of a new product, or you just invent a way to discover new data, or is both wrong? Okay, it does. I guess it does include invention of new products, but this is not something that is very easy to do. Products are usually invented. You need to work in a company that does data science products. There are a lot of startups around, but usually from a business perspective, you don't want to invent the products, you want actually to use the products. This is like driving a car. Unless you are some sort of a car enthusiast and petrol head, as they call them in Australia, you don't care how the car is built or who built it. You care how you can drive it. Of course, you care if the car is a Toyota or Ferrari, that's one thing, but you don't care about exactly how the car was built. This is the same here. So you want to actually get the data. You don't discover new data, you want to discover new information that would help you run your organization better. And then, yes, all right, some talk about not sharing on the screen. Yes, okay, we fix that. So this is all from me. Just any questions, please let me know. But